Hey everybody, this is Larry. This is September 25th in the year 2024. I don't know, I'm double checking my watch. I know it is 2024. Yeah, hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's random RNG prompt. Basically, on some days when I feel like I have enough energy, you saw my tabs. I do an algorithm RNG one a prompt I haven't done before because trying to get my money's worth on premium. And again, we have Yeezy for some reason. I feel like all the random ones have been Yeezy lately. But oh well, sometimes life gives you Yeezy lemons, so you make Yeezy lemonades. That's terrible. But anyway, let's take a look at today's farm. We have 628, maximum product of three numbers. It's easy. Given an integer array, nums find three numbers whose product is maximum and return the maximum product. Okay, so yeah, okay. I mean, I think this one could possibly be tricky, but example 3 kind of also, you know, yeah. I mean, just kind of be like, hey, remember negative numbers because that's the first thing I would think of because, well, otherwise this is pretty straightforward, right? It's just the three largest number if they're all positive. So okay, so I mean, there are really a couple of cases, right? So that if we want to be, so we can kind of spin them out, right? So we have three positive numbers, so just three biggest positive numbers. We have one positive number and two negative numbers, so it's going to be I suppose I'll write on next line because I don't know. So biggest positive in absolute value, and then the two biggest negative in absolute value, right? Reasonable. And then so these are ways to get the biggest positive number, but sometimes you're forced to have negative numbers if those don't go through, like in example 3, right? So then now if you have three negative numbers, then you just take three smallest negative numbers so that you know because you know that the answer is going to be negative, and then the other one is just two positive number and one negative, right? And I think that's all the cases, just because you have three positive, two positive, one positive, and zero positive. So anyway, so in this case, what do we want? We want oh yeah, I mean, this is going to give you a negative number, so you have two smallest positive and one smallest negative, right? By absolute value, you know. That's basically the idea. And here, I don't know. How do you want to implement it? And also, there's the other thing. Actually, I lied a little bit of an edge case, which is kind of actually there's a lot of edge cases for a easy problem, but it's just zero, right? I mean, if one exists, we should, we should use it if necessary. And what I mean by that is just like I would, if you want to reorder the way that we do these, then maybe zero would go obviously above the negative numbers, right? Something like this, so that this is the order we check, right? So then here maybe we have I'm just gonna be lazy and just write it out, right? Positive is equal to x for x in nums if x is greater than 0. Negatives, just write it out like this, right? Nums if x is in 0, and then has 0 is equal to nums dot count of 0 greater than 0 or something like this, right? And of course, as we kind of see with the biggest and the smallest, what we would like is have them sorted. So let's do that. You don't even, I mean, I'm just being lazy with the sorted. I think in theory, I mean, we don't have that many numbers, so I wouldn't worry about it. But in theory, if you really want to be optimal, then this is where you would use some sort of, well, just if you really want, you probably could just use if statements, but is what I mean. But another variation of that is just by heap, right? The idea being that, well, if we just want three biggest number or three biggest positive, you can keep track of that with if statements, and that's a linear time kind of thing that you can do, right? Because you just keep track of the top three manually, and cascading in down and stuff, and that's O of n, right? And you could do that for the smallest positive number and all these things for all these things. So definitely things that we can do, but for now, for today, being a little bit lazy, because that is just a lot of extra work, we'll sort them. But these are things that, you know, I guess on an interview, that's what you would probably do. But yeah, and then now we just have these cases that we already broken down. So here, maybe we have like, you know, biggest is equal to actually negative infinity, right? Because it could be negative. Infinity is just some random big number. And then now, what do we want to do? Yeah, 3 positive, right? So that's why I was up here, so that I could copy and paste while we do it. It's almost like a to-do list, right? Yeah, biggest, yeah, if the length of positives is greater than equal to 3, then we just take the bottom, or the last 3 is the biggest, right? So biggest is equal to max, biggest, and it should just by default be true with this particular one, which is positives of -1, which is the last element, the biggest element, the second biggest element, the third biggest element, right? Yeah, and then that's basically the idea. I'm just gonna run it real quick. Okay, that's good. No, because I thought that I have a typo somewhere, but sometimes, you know, you do this thing where you type the same word like 5 times and it just looks weird. I was having that for a second. Okay, so then now we have right. So then yeah, so then just add another if statement, right? So if positive is greater than 0, so we have at least one of them, and length of negatives is at least 2, right? Then now we do math, right? So the biggest number times well, the biggest negative would actually be in the front, right? The way we saw it. So we just do something like that, right? And we should be okay. And then now again, if we have 0, if has 0, then biggest is equal to max, 0 biggest. You can probably even return at this point. The only thing that is here is that these two things can have a different ordering. Like this, it's not clear which one will be bigger if you have, like, you know, a lot of numbers and satisfy both. But if neither of these happen and you have it has 0, then you could probably return it, but it's fine. We don't have to prematurely optimize, as I always say. Just kind of YOLO it, and then let Leetcode tell us that we have to optimize it, because Leetcode hates us anyway. Anyway, so yeah, so we have 3 negative numbers, and that's really, you know, hopefully at this point you're reading my mind. And biggest is equal to max, biggest, so negative sub 0, oh no, smallest, so it's gonna be from the end, yeah. But that's also why we write out the to-do list, because it's very easy to make silly mistakes, as you saw. Well, I mean, at least for me anyway, it's very easy to make silly mistakes, and I've been kind of doing that all day. But yeah, okay, so then yeah, and then now if positives is greater than equal to 2, and length of negatives is greater than or equal to 1. I don't know why I just write this differently, but yeah, and then we just kind of close it off, cap it off. We want the smallest positive, so that's going to be 0 times positives of 1 times smallest negative will be in the front, so -0. Oops, if I could type that. Yeah. Give a quick spin. Hopefully we're right, at least for the inputs or for the sample. Let's give it YOLO. Yeah, that's pretty much it. I mean, the only thing I worried about a little bit is just typos, to be honest. Like, it's very easy to you know, like, we have the idea, but it's very easy to grab stuff from the wrong end or something. And luckily we did not. But yeah, so what's the complexity here, right? I mean, we're going to be dominated by this sorting. So it's going to be n log n the way that we have it. Everything else is all of 1 pretty much. But as I said, you can actually optimize this by, you know, using like a top k algorithm where k is constant. So you could maybe use a heap if you like, but you can also just use if statements if you like. But you have to do it like 4 times, right? You have to get top 3, bottom 3, top 3, bottom 3. It's a little bit annoying, but you could do it, and then you're able to do this in linear time. And yeah, and in that case, I mean, this is actually linear space due to the sorting, but and dumping it here, but you can actually do this in constant space because, well, again, if you just get the top three, top three, bottom three, top three, bottom three, you'll be very Gucci. And it actually isn't that bad. I'm just a little bit lazy today. Ran 11 miles, but because you could just write it once and then all of them are just like inverted of each other in some way. Like smartness is just negative and then you read it. There are hacks you can do it, but nonetheless, that's all I have for this one. Let me know what you think. Thanks for watching. Let me know if you're observing it. And yeah, stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.